In the vast expanse of the cosmos, the question of whether life exists beyond Earth persists as one of the most profound and elusive inquiries in science. The search for extraterrestrial life is not merely a quest for entities in outer space, but a deeper probe into the fundamental aspects of life itself. What constitutes life? Could it have emerged elsewhere in our solar system or on exoplanets light years away? The potential for the evolution of intelligent life forms adds another layer of complexity to this cosmic puzzle. One of the primary considerations in the search for extraterrestrial life involves understanding the universal criteria for life. It is recognized that life on Earth is predominantly carbon-based, utilizing elements such as hydrogen, nitrogen, and oxygen, with water serving as a crucial medium for molecular interactions. This composition raises a pivotal question. Are these elements and conditions exclusively conducive to life, or could life elsewhere in the universe thrive under different conditions? The exploration of these questions employs a variety of scientific methods, each designed to uncover a part of the enigma surrounding extraterrestrial life. From astrobiology to exoplanet research, scientists utilize advanced technologies to detect and analyze distant planets. The identification of exoplanets within the habitable zone of their stars, where conditions might allow liquid water to exist, is particularly promising. These studies often involve sophisticated telescopes and space observatories equipped to observe the atmospheric compositions of these planets, searching for biosignatures like oxygen and methane that could indicate the presence of life. The conditions on these distant worlds are inferred from our understanding of life's requirements on Earth, such as the presence of an atmosphere, a solvent medium like liquid water, and an energy source, usually from a star. Thermodynamically, it is understood that life on Earth benefits from the energy disparity between the cooler planetary surface and the much hotter sun. This principle guides the search for planets around stars where similar energy disparities could allow life-sustaining chemical reactions. However, the existence of life might also depend on specific planetary characteristics that are not universally guaranteed. For instance, the role of plate tectonics in cycling essential elements and shaping a dynamic environment might be critical, yet such geological activity is not observed on all planets. This introduces a significant variable in the quest to understand extraterrestrial environments that could support life. As this search continues, each discovery feeds into the larger scientific narrative of our universe's complexity and the potential diversity of life within it. The ongoing exploration not only broadens our understanding of where life might exist, but also deepens our appreciation of the rare and perhaps unique conditions that have fostered life on Earth. With each hypothesis tested and every new world discovered, the quest to answer the tantalizing question of extraterrestrial life continues to unfold, pushing the boundaries of human knowledge and technology. As the exploration into the possibility of extraterrestrial life advances, understanding the basic requirements for life remains a cornerstone of astrobiological research. Life, as it is known on Earth, hinges on several critical elements and conditions that may also be universal, or at least indicative of life-supporting environments elsewhere in the cosmos. At the core of life's chemical foundation are the elements carbon, hydrogen, nitrogen, and oxygen. These elements are prevalent in the universe, and on Earth, they form the building blocks of complex molecules such as proteins, nucleic acids, and carbohydrates. Carbon, in particular, is renowned for its ability to form stable, complex structures with itself and other elements, a property known as catenation. This capability makes carbon an ideal backbone for the intricate molecules that constitute living organisms. Water serves as the quintessential medium for biochemical interactions necessary for life on Earth. Its unique properties as a solvent enable the transportation and mixing of nutrients, the facilitation of chemical reactions, and the disposal of waste products at the cellular level. Water's polarity and ability to form hydrogen bonds make it an exceptional solvent, supporting the theory that liquid water is critical in extraterrestrial environments conducive to life. However, the possibility of alternative biochemistries in extraterrestrial life forms prompts scientists to consider environments that deviate significantly from terrestrial norms. For instance, Other solvents, such as ammonia or hydrocarbons like methane, could potentially support life under the right conditions. These solvents would necessitate a different chemical makeup and possibly a different set of elemental requirements. For example, life forms based on silicon, a chemical analog to carbon, could theoretically exist in environments too hot for water to remain liquid, but suitable for silicon-based molecules which can remain stable at higher temperatures. In addition to carbon and water, nitrogen plays a crucial role in terrestrial life, primarily through its inclusion in amino acids and nucleic acids. The versatility of nitrogen in forming various organic compounds supports its potential necessity in extraterrestrial life. Similarly, phosphorus is integral to forming DNA and RNA, and in the energy transfer within cells through molecules like ATP, adenosine triphosphate, suggesting these elements could be universal to life as we conceive it. The environmental conditions supporting life extend beyond just chemical composition. The stability of an organism's structure and the ability of its molecular systems to engage in chemical reactions are influenced by external conditions like temperature, pressure, and radiation levels. Life on Earth has adapted to a vast range of these conditions, but the limits of life in extreme extraterrestrial environments remain a subject of ongoing research. By examining the roles of these fundamental elements and conditions, scientists aim to broaden the criteria for life-supporting environments. This approach not only aids in the targeted search for life beyond Earth, but also helps refine the understanding of life's potential diversity throughout the universe. Each investigation into these elements and their interactions in different planetary contexts contributes to a more comprehensive picture of where and how life could exist beyond the familiar confines of Earth. Transitioning from the basic chemical and environmental requisites for life, the role of plate tectonics introduces a geological dimension to the understanding of life's complexity and evolution. On Earth, the movement of tectonic plates has been a significant factor in the development of complex life forms. This dynamic geological process involves the shifting of large plates that make up Earth's crust, driven by the heat from the planet's interior. The interactions between these plates have profound effects on the planet's surface and its life forms, influencing everything from climate patterns to the distribution of nutrients. The significance of plate tectonics in supporting life extends beyond merely creating a dynamic environment. It also involves the recycling of materials through the subduction of plates, where one plate slides under another back into the mantle. This recycling process is crucial for regulating the atmosphere's composition and maintaining the chemical balances that are conducive to life. Moreover, the geological activity associated with tectonics, such as volcanic eruptions and the formation of mountains, plays a vital role in the carbon cycle, helping to stabilize the planet's climate over geological timescales. Researchers Robert Stern of the University of Texas at Dallas and Teres Garia of ETH Zurich have emphasized the essential role of plate tectonics in the evolution of intelligent, technological life. Their studies suggest that the onset of modern-day-style plate tectonics significantly accelerated the evolution of complex life on Earth, contributing to diverse habitats and complex ecological networks. This geological process was one of the major factors driving the Cambrian explosion, a pivotal event approximately 539 million years ago when most major animal phyla appeared. Stern and Garia argue that the presence of plate tectonics, along with oceans and continents, creates a uniquely stable yet dynamic environment that may be necessary for the development of complex, intelligent life forms capable of creating technology. The combination of liquid water, continental land masses, and active geological processes contributes to a planet's habitability by facilitating nutrient cycles, creating varied ecological niches, and promoting biodiversity. However, the rarity of plate tectonics in the known universe presents a challenge in the search for extraterrestrial life. Earth remains the only known planet with active plate tectonics, and this rarity might extend to other rocky planets. Many exoplanets discovered so far appear to have stagnant lid tectonics, where the crust is a single, unbroken shell rather than a series of moving plates. This difference could significantly impact the likelihood of complex life evolving on those planets. The implications of these findings are profound, suggesting that planets with the necessary geological activity for complex life may be exceedingly rare. This rarity underscores the exceptional nature of Earth and raises important questions about the distribution and diversity of life in the universe. As the search for life beyond Earth continues, understanding the role of plate tectonics and its effects on a planet's ability to support life remains a critical area of study, informing both the search for extraterrestrial life and the appreciation of Earth's unique biological heritage. Among the myriad of exoplanets discovered, LHS 1140b stands out as a particularly intriguing candidate in the search for extraterrestrial life. Situated in the habitable zone of its star, this exoplanet exhibits several characteristics that suggest it might support conditions favorable for life. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist on a planet's surface, an essential ingredient for life as we know it. LHS 1140b is approximately 1.7 times the size of Earth and is located about 48 light-years away. This proximity in cosmic terms allows astronomers to study the planet in considerable detail. Research indicates that LHS 1140b may possess a rocky composition with a significant amount of its mass potentially consisting of water, estimated to be between 10 to 20%. These findings point to the exciting possibility that the planet could host a substantial liquid ocean beneath its surface, similar to theories proposed for Jupiter's moon Europa. The presence of an atmosphere on LHS 1140b further heightens the interest in this exoplanet. An atmosphere can play a critical role in maintaining surface water in a liquid state, providing protection from harmful space radiation and potentially contributing to the right conditions for life. Recent observations suggest that LHS 1140b's atmosphere could contain a similar amount of nitrogen to Earth's, which is crucial since nitrogen is a key component of the air we breathe and a fundamental building block in the chemistry of life. The implications of these findings are profound. If LHS 1140b does indeed have an atmosphere and a significant ocean, it would join a select group of known exoplanets with conditions that could be comparable to those on Earth. However, it is essential to note that being in the habitable zone and having water does not necessarily mean that LHS 1140b harbors life. The exoplanet's environment could be very different from Earth's in other ways that might affect its habitability. When comparing LHS 1140b to other exoplanets in habitable zones, it becomes evident that each planet presents a unique case. Factors such as the type of star the planet orbits, the planet's size, atmospheric composition, magnetic field, and geological activity contribute to its overall habitability. For example, planets orbiting red dwarf stars, like LHS 1140b, must contend with high levels of stellar activity that can strip away atmospheres and bombard surfaces with harmful radiation, unless mitigated by strong magnetic fields or other protective factors. The study of LHS 1140b not only advances the understanding of potentially habitable exoplanets, but also highlights the diversity and complexity of planetary systems beyond our solar system. Each discovery adds a piece to the puzzle of the universe's habitability and brings us closer to answering the age-old question, are we alone in the universe? As observational technologies continue to improve, future missions may be able to probe the atmosphere of LHS 1140b more deeply, searching for signs of life or biosignatures that could reveal whether this distant world might indeed be a second Earth. As the search for extraterrestrial life gains momentum, the future of space exploration is poised to be transformed by groundbreaking missions and technological innovations. One of the most ambitious initiatives in this realm is NASA's Habitable Worlds Observatory, HWO, a mission that epitomizes the next generation of astronomical observation. The HWO is specifically designed to identify and characterize potentially habitable planets beyond our solar system, pushing the boundaries of human knowledge about the cosmos and the prevalence of life within it. The primary objective of the Habitable Worlds Observatory is to detect at least 25 exoplanets that reside in the habitable zones of their respective stars. These are the regions where conditions might be right for liquid water to exist, which is a crucial factor for life as we understand it. To achieve this, the HWO will employ advanced spectroscopy techniques to analyze the atmospheres of these planets. By examining the light from a star as it passes through a planet's atmosphere, the observatory can identify the chemical makeup of the atmosphere, including potential biosignatures like oxygen, methane, and other organic compounds. The technological advancements integral to the HWO mission are set to surpass the capabilities of current space telescopes. The observatory will feature a primary mirror significantly larger than that of the Hubble Space Telescope, enhancing its ability to capture detailed, high-resolution images of distant planetary systems. This large mirror, coupled with a suite of sensitive instruments, will allow the HWO to observe a wide range of wavelengths, from ultraviolet to near-infrared light, providing a comprehensive view of the planetary atmospheres it studies. Beyond its primary mission of planet hunting, the Habitable Worlds Observatory will contribute to a broader understanding of astrophysical phenomena. The data collected will offer insights into the formation and evolution of planetary systems, the dynamics of stellar activity, and the distribution of potentially habitable environments across the galaxy. These findings will not only inform the ongoing search for life, but also deepen the understanding of the fundamental processes that govern the universe. The impact of the HWO and similar future missions on science is expected to be profound. By directly imaging exoplanets and analyzing their atmospheres, astronomers will move closer to determining whether Earth-like planets are common or rare in the galaxy. This could fundamentally shift the perspective on Earth's place in the universe and enhance the understanding of conditions that lead to the emergence of life. Moreover, the technologies developed for the HWO mission will have broader applications, potentially benefiting other areas of space exploration and observation. The advancements in optics, light filtering, and data analysis could improve the performance of satellites, enhance Earth observation capabilities, and even contribute to telecommunications technologies. As humanity stands on the brink of these exciting developments, the future endeavors in the search for extraterrestrial life promise not only to expand the frontiers of science, but also to inspire new generations to look up at the stars with wonder and curiosity about the possibilities of life beyond our own planet. The journey of discovery continues, driven by innovation and the enduring human quest to explore the unknown. Elon Musk, the CEO of SpaceX and a figure synonymous with groundbreaking technology and ambitious space exploration, has intensified his focus on a project that could redefine human civilization, colonizing Mars. With an estimated net worth of about $270 billion, Musk's vision extends far beyond commercial success on Earth. He envisions a self-sustaining city on Mars, a goal that has driven almost every business venture he has embarked upon. For over 2 decades, Musk has steered SpaceX toward achieving his lifelong goal of reaching Mars. In recent developments, Musk has accelerated the timeline for this monumental endeavor. Initially stating in 2016 that it would take 40 to 100 years to establish a self-sustaining civilization on Mars, he informed SpaceX employees in April that he now expects 1 million people to inhabit Mars within approximately 20 years. Musk's directive to his teams at SpaceX has been to delve into the specifics of constructing a Martian city. This includes the development of small dome habitats, designed to withstand the planet's harsh conditions, and the creation of spacesuits tailored to protect future residents from the hostile Martian environment. Additionally, a medical team at SpaceX is exploring the feasibility of human reproduction on Mars, a critical aspect of establishing a permanent colony. Despite the ambitious goals, the technical and logistical challenges are immense. No human has set foot on Mars, and the terrain offers nothing less than icy temperatures, frequent dust storms, and an atmosphere that is inhospitable to human life. Moreover, NASA does not anticipate landing humans on Mars until the 2040s, underscoring the technological strides still required to make Mars colonization a reality. Musk's plans are not just confined to technology and space exploration. He envisions a comprehensive ecosystem supporting life on Mars, which involves contributions from his other enterprises. The Boring Company, initially founded to improve tunnel construction on Earth, is part of Musk's strategy to create underground habitats on Mars. Furthermore, Musk's acquisition of the social media platform X is partly aimed at experimenting with new forms of governance, potentially suitable for a Martian society. Musk also sees Tesla's Cybertrucks being adapted for transportation on the Red Planet. Skeptics and critics argue that Musk's vision, while compelling, faces astronomical odds. Aerospace experts like Robert Zubrin, who has known Musk for 2 decades, believe that establishing a colony on Mars would unfold over decades, not years. Moreover, the distraction of managing multiple high-stakes ventures simultaneously has led some to question Musk's capacity to realize his Martian dream within his lifetime. Despite these challenges, Musk's commitment to colonizing Mars continues to drive SpaceX's agenda, with the company even partnering with firms like Impossible Foods to explore sustainable food sources for future Martian residents. As audacious as it may seem, Musk's vision of a Martian city underscores a broader ambition to ensure humanity's survival and prosperity far beyond the confines of Earth. Whether this vision will materialize remains to be seen, but it undoubtedly sets the stage for one of the most extraordinary endeavors in human history. Continuing from the audacious vision of constructing a Martian city, the focus narrows down to overcoming the architectural and environmental challenges crucial for sustaining life on the hostile Martian surface. The teams at SpaceX are deeply engaged in designing and constructing small dome habitats, which are pivotal to the survival of future Martian residents. These dome habitats, which are being meticulously planned, must be resilient enough to withstand Mars' extreme conditions, including sub-zero temperatures, intense radiation, and massive dust storms. The materials under consideration for these structures involve advanced, lightweight composites that are capable of providing insulation and radiation shielding, yet are feasible to transport from Earth to Mars. Researchers are exploring the utility of materials like aerogel, a substance known for its low density and excellent insulating properties, and testing the adaptability of Martian regolith as a potential building material. These habitats are designed to be small domes, primarily because their geometric shape offers maximum durability and efficient distribution of stress, crucial for surviving Mars' frequent dust storms and thin atmosphere. The compact design also aids in maintaining and regulating the internal atmosphere, an essential factor for human habitation. Parallel to the development of dome habitats, there is a significant advancement in spacesuit technology, tailored specifically for Mars's harsh environment. The traditional spacesuits, designed for moonwalks or spacewalks, are inadequate for Mars conditions, which involve greater mobility and long-term exposure to surface conditions. The new generation of spacesuits aims to be more flexible, durable, and equipped with life support systems that can handle the drastic temperature swings and high radiation levels on Mars. These suits are also being designed to facilitate easier self-repair, crucial for prolonged missions where immediate technical support from Earth will not be available. Each of these elements, from the structural designs of the habitats to the materials selected for construction and the features of the spacesuits, are being developed with a dual focus on functionality and sustainability. This meticulous planning not only addresses the immediate challenges of Mars' environment, but also lays the groundwork for future scalability, as the vision of expanding from initial small colonies to a thriving city becomes a tangible goal. These foundational aspects ensure that as more individuals arrive on Mars, the infrastructure will be equipped to accommodate growth while maintaining the safety and well-being of its residents. This approach underscores a commitment not just to landing humans on Mars, but to fostering a viable, enduring human presence on the Red Planet. Transitioning from the technological and architectural preparations for Mars colonization, attention shifts to the biological and social considerations that are equally pivotal for sustaining a human population on Mars. One of the most significant and complex issues being tackled by SpaceX's medical team is the feasibility of human reproduction on the Martian surface. Concerns about the effects of Mars's higher radiation levels and lower gravity on human health are profound, especially when it comes to reproduction. Radiation can cause significant damage to DNA, which might lead to serious genetic disorders, while lower gravity could affect fetal development and the overall reproductive process. The medical team at SpaceX is conducting extensive research to understand and mitigate these risks. This involves studying the potential for creating shielded areas within habitats that could reduce radiation exposure and analyzing data from astronauts who have spent extended periods in low-gravity environments to predict how human bodies might respond on Mars. Parallel to these scientific inquiries, Elon Musk made headlines with his controversial offer to contribute his sperm to help seed a Martian colony. This statement, whether serious or hyperbolic, underscores his personal commitment and the symbolic dedication to his vision of life on Mars. Musk's proposition has sparked a broad discussion about the ethical, psychological, and social implications of creating a new human population from a narrow genetic pool. It also raises questions about the social structures that would be needed to support a balanced and healthy community on Mars. This revelation ties into broader considerations of what Martian society might look like. As pioneers on a new world, the first Martian settlers will need to establish social norms, governance structures, and community support systems that are adaptable to the unique challenges of living on another planet. The role of digital platforms, possibly modeled on Musk's ownership of the social media platform X, could play a significant role in forming a consensus-based democratic governance system among Martian settlers. In this context, the biological and social frameworks being developed are not only about survival, but about creating a sustainable and thriving community that could one day grow into a civilization. The research into reproduction and the discussions sparked by Musk's personal commitments are laying the groundwork for a society that extends beyond mere habitation to a dynamically functioning civilization capable of enduring on Mars. This forward-thinking approach ensures that every aspect of human life, including the most fundamental elements like reproduction and social interaction, is meticulously planned and integrated into the Mars colonization roadmap. As the blueprint for Mars colonization becomes more detailed, the role of supporting technologies and infrastructure developed by Elon Musk's suite of companies becomes increasingly pertinent. These technologies are not just supplementary, but are integral to the feasibility and efficiency of establishing and expanding a Martian colony. The Boring Company, initially started to revolutionize tunneling on Earth, has potential applications on Mars that could be game-changing. The harsh surface conditions of Mars make living underground a practical option for protecting against radiation and extreme temperature fluctuations. The tunneling technology developed by the Boring Company could facilitate the construction of extensive underground habitats. These habitats would not only provide safer living quarters, but could also house agricultural zones and industrial operations, shielded from the Martian elements. This approach could substantially increase the colony's chances of self-sufficiency. In terms of transportation, Tesla's innovations could also be transformative on Mars. The Tesla Cybertruck, with its durable, ultra-hard stainless steel exoskeleton, offers a model for vehicles that could navigate the rugged Martian terrain. The electric nature of Cybertrucks aligns with the sustainability goals of the Mars colony, considering that solar power could be a primary energy source on the planet. Modifications might be needed to adapt these vehicles to the thin Martian atmosphere and extreme cold, but the fundamental design presents a robust starting point for developing efficient, reliable Martian transportation. Beyond the physical infrastructure, the colonization of Mars also presents unique challenges and opportunities in social organization and governance. Musk's acquisition of the platform X, formerly known as Twitter, could play a crucial role in this aspect. On Mars, traditional Earthbound forms of government may not be practical, especially in the early stages of colonization, when the population will be small and highly dependent on technology for survival. X could serve as a platform for experimenting with new forms of digital democracy and consensus-based decision-making. This platform could enable every colonist to have a say in decisions, from resource allocation to development priorities, thereby fostering a cohesive and engaged community. The potential use of X also highlights the importance of communication in maintaining a unified social structure on Mars. It could facilitate not only governance, but also provide essential social connections, helping to combat the isolation and confinement that could be challenging for inhabitants of a new planet. These supporting technologies and infrastructure, spearheaded by Musk's ventures, underscore a comprehensive strategy for Mars colonization that integrates advanced engineering with innovative governance models. This integration ensures that the Mars colony could be sustainable not just technologically and environmentally, but also socially and politically. The vision for Mars is not just to create habitable spaces, but to establish a thriving, dynamic community that could serve as a model for future extraterrestrial colonies. In an era where interstellar exploration remains within the realm of science fiction, the study of exoplanets, planets orbiting stars beyond our own solar system, offers a tangible connection to the vast cosmos. The year 2024 has seen a remarkable influx of information in the field of exoplanet research, thanks to the diligent updates from the Exoplanet Archive. The Exoplanet Archive serves as a comprehensive repository, chronicling the discovery and characteristics of these distant worlds. It's a testament to the relentless pursuit of knowledge, where astronomers and scientists contribute data that continually reshape the understanding of the universe. From the detection of new planets to the refinement of parameters for known ones, the archive is a dynamic resource that reflects the current state of exoplanetary science. In a significant update on June 27th, the archive announced the discovery of 8 new planets, including a trio of transiting sub-Neptunes found within a single system, named TOI 663b, C, and D. These discoveries were made possible by NASA's Transiting Exoplanet Survey Satellite, commonly known as TESS. Additionally, 2 metal-rich sub-Saturns located within the Neptunian desert, TOI 2374b and TOI 3071b, were added to the archive's ever-expanding list. The Neptunian desert is a region close to a star where Neptune-sized planets are rarely found, making these discoveries particularly intriguing. Further enriching the archive's database, new spectra were added for the exoplanet WASP-6b, captured by the Magellan Walter Baade telescope. These spectra enhance understanding of exoplanetary atmospheres, a critical aspect of determining a planet's composition and potential habitability. Another noteworthy update on May 23rd introduced 2 Earth-sized planets orbiting M-dwarfs, Gliese 12b and Speculoos 3b. These nearby worlds are considered prime candidates for follow-up studies with the James Webb Space Telescope. The proximity of these planets, at 40 and 55 light-years away respectively, presents a valuable opportunity for detailed observation and analysis. The archive's dedication to accuracy is evident in the reclassification of Kepler 488b as a false positive. This rigorous approach to data integrity ensures that the archive remains a reliable source of information for researchers around the globe. Furthermore, the discovery of M62HB, a pulsar companion located in the Messier 62 globular cluster, marks a rare and fascinating addition to the archive's collection. Pulsar planets are unusual, as they orbit neutron stars, which are the remnants of massive stars that have undergone supernova explosions. As the Exoplanet Archive continues to assimilate data, including new spectra from the Hubble Space Telescope and TESS, the field of exoplanet research is propelled forward. These updates not only represent the discovery of new worlds, but also the refinement of our understanding of the diverse properties and potential environments of exoplanets. The quest to explore these distant celestial bodies is bolstered by the collective efforts of the global scientific community, as well as the advent of advanced observational technologies. With each planetary system meticulously cataloged and each spectrum analyzed, a clearer picture of the cosmos emerges, offering insights into the conditions that may give rise to life beyond Earth. This journey into the cosmos, driven by curiosity and the hunger for knowledge, underscores humanity's unyielding desire to grasp the mysteries of the universe. The Exoplanet Archive, a chronicle of celestial discovery, has expanded with a wave of new entrants in 2024, each telling a unique story of the cosmos. The addition of Earth-sized planets orbiting the most common type of star in our galaxy, the M-dwarfs, is particularly noteworthy. These planets, Gliese 12b and Speculoos 3b, epitomize the significant strides made in exoplanet detection. Gliese 12b, situated a mere 40 light-years away, is now recognized as the closest transiting temperate, Earth-sized world found to date. Its discovery, as detailed in the works of Kuzuhara et al. And Dolakia et al., has been heralded with keen interest due to its potential for detailed atmospheric study by upcoming missions such as the James Webb Space Telescope. The data visualization and media release by NASA provide a tangible connection to this distant world, fueling both scientific endeavor and public imagination. Speculoos 3b, approximately 55 light-years distant, is another gem in the exoplanetary crown. Discovered by the Speculoos project, this tidally locked exoplanet offers a unique laboratory for studying atmospheric dynamics and composition in conditions vastly different from those on Earth. The discovery paper, published in the prestigious journal Nature, underscores the importance of international collaboration and the utilization of a global array of telescopes in unveiling planetary secrets. The pulsar planet M62HB presents an entirely different class of exoplanets. Found in the ancient stellar nursery of the Messier 62 globular cluster, this planet orbits a pulsar, a rapidly spinning neutron star that remains after a supernova explosion. The detection of M62HB, made by the South African Meerkat radio telescope, represents a breakthrough in the study of planets associated with the extreme environments of pulsars. These discoveries not only add to the tally of known exoplanets, but also amplify the scientific community's understanding of planet formation and survivability in diverse cosmic settings. Each new world presents an opportunity to refine theories, develop new observational strategies, and perhaps, one day, unlock the secrets of life's potential beyond the solar system. The Exoplanet Archive's meticulous record-keeping encapsulates the essence of these discoveries, preserving the data for future generations of researchers and providing a touchstone for ongoing explorations in the search for worlds like and unlike our own. The exploration of exoplanets is propelled by a suite of sophisticated instruments and missions, each designed to pierce the veil of interstellar space and reveal the secrets of distant worlds. NASA's Transiting Exoplanet Survey Satellite, or TESS, has been instrumental in this endeavor, serving as a prolific hunter of exoplanets since its launch. TESS scans the sky, mapping out large swaths to detect the minute dips in starlight that occur when planets transit their host stars. Its contribution to the field is evident in the numerous planetary discoveries populating the Exoplanet Archive. Complementing the work of TESS is the James Webb Space Telescope, known as JWST. Poised to become the premier observatory of the next decade, JWST promises to offer unprecedented insights into the atmospheres of exoplanets. Its infrared capabilities allow it to dissect the composition of exoplanetary atmospheres, probing for the molecular fingerprints of water vapor, carbon dioxide, methane, and other potential signs of habitability. JWST's sensitivity and precision are expected to revolutionize the understanding of planetary climates and surface conditions. On the horizon, the Pandora smallsat mission exemplifies NASA's commitment to exoplanetary science. This mission is tailored to disentangle the signals emanating from stars and their planets, a challenge in the study of exoplanetary atmospheres. By observing in both visible and infrared wavelengths, Pandora aims to refine measurements of atmospheric constituents and provide a clearer picture of planetary environments. The smallsat, scheduled for a 2025 launch, stands as a testament to the ingenuity and foresight of current scientific endeavors, representing a targeted approach to answering fundamental questions about the nature of planets beyond the solar system. These technological triumphs are not merely feats of engineering, they are the fundamental tools that enable a deeper understanding of the cosmos. As these instruments operate in concert, they refine the celestial census and shed light on the diverse range of exoplanetary systems. The data they collect feed into the Exoplanet Archive, enriching the tapestry of knowledge with every spectral line and transit curve. The synergy between these cutting-edge missions and the Archive's meticulous dataset is driving a golden age of discovery, revealing the complexity and beauty of the universe's planetary mosaic. The quest to comprehend the cosmos extends beyond the realm of professional astronomers and into the hands of citizen scientists across the globe. Exoplanet Watch, a cornerstone of collaborative science, exemplifies the power of community engagement in the field of exoplanetary research. This initiative harnesses the enthusiasm and effort of individuals from varied backgrounds, empowering them to contribute to the study of planets beyond the solar system. Exoplanet Watch provides a platform for amateur astronomers and enthusiasts to participate in cutting-edge science. By observing transits of known exoplanets and analyzing the data, these citizen scientists play a vital role in refining orbital parameters and confirming the existence of new worlds. Their observations often complement those made by professional observatories, filling gaps in data and extending the temporal coverage of transit events. The contributions of these dedicated individuals are not to be underestimated. They have been instrumental in reducing the uncertainty of exoplanet transits, such as those of WASP-12b and WASP-18, through meticulous observation and data analysis. The collective efforts of Exoplanet Watch participants have led to the publication of scientific papers, cementing their place within the scientific discourse and contributing valuable insights to the field. Furthermore, Exoplanet Watch serves as an educational tool, providing resources and tutorials that demystify the process of scientific discovery. The program offers step-by-step guides on data acquisition and analysis, making the science of exoplanets accessible to novices and seasoned observers alike. By engaging with Exoplanet Watch, individuals gain not only scientific knowledge, but also experience in research methodologies and data interpretation. Outreach efforts such as online meetings and the sharing of best practices encourage a sense of community and foster a collaborative spirit among participants. These interactions provide a forum for knowledge exchange where ideas and experiences are shared freely, enhancing the educational experience for all involved. The foundation of Exoplanet Watch on the principles of open science and inclusivity has broadened the scope of exoplanet research. By inviting the public to partake in the discovery process, the initiative is not only expanding the boundaries of what is known, but also nurturing the next generation of scientists. The engagement of citizen scientists ensures that the study of exoplanets is a shared human endeavor, propelled by a collective curiosity and a shared desire to unlock the secrets of the universe. The Exoplanet Watch program stands as a beacon of collaborative science, where the amalgamation of professional acumen and amateur passion coalesces into a formidable force for astronomical discovery. This initiative, aimed at harnessing the collective power of citizen astronomers, has cultivated a robust community dedicated to monitoring and analyzing the transits of exoplanets. A deeper examination of the program reveals a treasure trove of resources designed to equip participants with the tools necessary for meaningful contribution. Tutorials crafted by experts guide users through the nuances of data collection and reduction, employing software such as Exotic, the Exoplanet Transit Interpretation Code. This user-friendly software enables enthusiasts to transform raw observations into refined light curves, the graphical representation of a planet transiting its host star. Outreach efforts are pivotal to the program's success, and Exoplanet Watch has developed an innovative array of strategies to engage the community. Online meetings serve as a conduit for participants to connect with leaders in the field, offering a forum for dialogue and the exchange of ideas. These sessions delve into diverse topics, from optimizing observation techniques to leveraging exoplanet transits as educational opportunities. The impact of community involvement is palpable in the achievements of Exoplanet Watch. The collective contributions have led to the refinement of planetary ephemeroids and have even played a part in the discovery of new exoplanets. The program's publications page stands as a testament to the scientific value of these collaborative efforts, listing an ever-growing number of peer-reviewed papers that feature data contributed by citizen scientists. Past meetings have highlighted the program's multifaceted nature, addressing subjects such as the integration of exoplanet research into the classroom and the intersection of exoplanetary science with fields like geoscience and aeronomy. These gatherings not only disseminate knowledge, but also inspire participants to apply their learning in innovative ways. Looking to the future, Exoplanet Watch envisions an even more dynamic role for citizen scientists in the realm of exoplanetary exploration. With plans to incorporate more advanced observational campaigns and to foster a wider international participation, the program anticipates an increase in both the quantity and quality of data contributed by the public. This, in turn, will continue to refine the understanding of distant planetary systems and may even aid in the identification of potentially habitable worlds. The Exoplanet Watch experience is emblematic of the transformative potential of community-driven science. By providing a platform for public participation, the program not only democratizes the field of exoplanet research, but also enriches it, proving that the journey to unravel the mysteries of the cosmos is a path best traveled together. In theory, warp drives could allow an object to travel faster than light by manipulating the space-time surrounding it. The concept of warp drives, initially a product of science fiction literature, gained popularity through the Star Trek franchise and was later conceptualized in a scientific context by theoretical physicist Miguel Alcubierre in 1994. Alcubierre's proposal of a device, now known as an Alcubierre drive, involves the creation of a warp bubble that contracts space-time in front of it and expands it behind, allowing the object to move faster than light by moving the universe around it. Despite the conceptual validation of the physics behind the Alcubierre drive, the creation of such a device faces significant challenges, including the requirement of negative energy and the potential for creating closed space-time loops that violate causality. Physicist Don Lincoln from Fermilab in Illinois suggests that a breakthrough in our understanding of physics may one day make warp drives a reality, enabling humanity to explore the cosmos in ways currently unimaginable. The possibility that advanced alien civilizations might have already achieved this feat has led to speculative research on how humanity could detect their presence through the aftermath of warp drive usage. A recent study, uploaded to the preprint server Arxiv, proposes that the use of warp drives by alien civilizations could leave detectable traces in the form of specific gravitational waves generated by the creation and destruction of warp bubbles. According to Katie Clough, a theoretical physicist at Queen Mary University of London and co-author of the study, the collapse of a warp bubble could produce a strong gravitational wave event with a unique wavelength. This suggests that, in theory, advanced observatories like the Laser Interferometer Gravitational Wave Observatory, LIGO, could potentially detect these unique gravitational waves, different from those generated by phenomena such as black hole collisions or wobbling dark matter. However, the likelihood of detecting such gravitational waves remains uncertain, with Clough herself expressing skepticism but also acknowledging the significance of the endeavor. The search for gravitational waves produced by hypothetical warp drives would require observatories to tune into a different range of wavelengths, an effort that might prove fruitless but is considered by some researchers to be worth the attempt in the quest to uncover evidence of super-advanced alien technologies and perhaps, one day, make interstellar travel a reality for humanity. The universe is a vast and mysterious place, and one of the most profound questions we can ask is about its ultimate fate. What will happen to the cosmos in the distant future? Will it continue to expand forever, or will it eventually collapse in on itself? These are questions that have puzzled scientists and philosophers for centuries, and while there are no definitive answers, there are some fascinating theories that offer glimpses into the possible futures of the universe. One possibility is that the universe will eventually stop expanding and begin to contract, leading to a cataclysmic event known as the Big Crunch. This scenario is based on the idea that gravity will eventually overcome the outward expansion of the universe, pulling all matter back together. As the universe contracts, galaxies would collide, stars would fuse into massive black holes, and ultimately, the entire universe would collapse into a singularity, a point of infinite density and temperature, similar to the conditions that existed before the Big Bang. However, recent observations suggest that the universe is actually expanding at an accelerating rate, driven by a mysterious force known as dark energy. This makes the Big Crunch scenario less likely, as dark energy appears to be counteracting the effects of gravity. Another possibility is that the universe will continue to expand forever, eventually becoming cold and empty. This scenario, known as the Big Freeze or heat death, envisions a universe where all stars eventually burn out, leaving behind only a sea of black holes and dark energy. As the universe expands, the average temperature will continue to decrease, eventually reaching a point where all activity ceases. This would be a universe where time itself would essentially come to a standstill. The Big Freeze scenario is supported by the fact that the universe is expanding at an accelerating rate, and there is no evidence to suggest that this expansion will ever stop. However, some scientists argue that the existence of dark energy could eventually lead to a different fate for the universe. A more dramatic scenario is the Big Rip, where the accelerating expansion of the universe becomes so powerful that it rips apart all matter, including galaxies, stars, planets, and even atoms. This scenario is based on the idea that dark energy is not a constant force, but rather a force that is increasing in strength over time. If this is the case, then eventually the repulsive force of dark energy will overcome the gravitational forces holding matter together, causing the universe to tear itself apart. The Big Rip is a controversial theory, and there is no conclusive evidence to support it. However, it remains a fascinating possibility that highlights the potential for unexpected and dramatic changes in the universe's future. Dark energy is a mysterious force that makes up about 70% of the universe's energy density. It is responsible for the accelerating expansion of the universe, and its influence on the universe's fate is still being studied. Some theories suggest that dark energy could eventually become so powerful that it tears apart the fabric of space-time, leading to a Big Rip scenario. Others suggest that dark energy could eventually weaken, allowing gravity to take over and lead to a big crunch. The ultimate fate of the universe remains a mystery, but the theories developed give a glimpse into the possible futures that await. Whether the universe ends in a fiery big crunch, a cold big freeze, or a dramatic big rip, one thing is certain: the universe is a dynamic and ever-changing place, and its future holds many surprises. As exploration of the universe continues, more will be learned about its past, present, and future. The pursuit of knowledge about the universe's fate is a testament to curiosity and the desire to understand the place in the cosmos. And while all the answers may never be known, the journey of discovery is just as rewarding as the destination itself. In considering the philosophical implications of these cosmic outcomes, the works of Albert Camus and his theory of absurdism resonate deeply with the concept of the universe as a finite, indifferent entity. Camus posited that existence is absurd, lacking any prolongation into eternity, rendering human effort meaningless in the grand scheme. Cultures, civilizations, and individual actions are bound to disappear, and without witnessing anything after death, the absolute value of efforts is negated. In the myth of Sisyphus, Camus explores what it means for individual lives and the kind of happiness that can be attained within this framework. Since the result of endeavors won't matter in the end, it is the endeavor itself and the joy it brings that matters, albeit only to the individual and as long as they are alive. For instance, the act of raising children and the joy it brings is significant, not the long-term outcome of such actions. If raising children brings no joy, then it is better not to engage in it. This perspective suggests that even in light of the universe's possible cold and empty future, the present moments and the meaning derived from current actions are where focus and value should be placed. The big freeze, big crunch, or big rip may dictate the ultimate large-scale fate of the universe, but it is the smaller human experiences within it that define a life's worth. Embracing the present endeavors and the happiness they bring may be the most profound response to the universe's inevitable end. In the face of the universe's grandeur and the potentially grim fates that await it, human efforts may seem insignificant. This notion is at the heart of Albert Camus' philosophy of absurdism, which confronts the lack of inherent meaning in life against an indifferent cosmos. Camus argues that the realization of life's ultimate futility in the grand scheme can provoke a sense of absurdity. This sense is not rooted in despair, but in the understanding that human actions, while not eternally significant, hold meaning in the moment. Absurdism does not advocate for nihilism or inaction. Instead, it challenges individuals to embrace the journey of life with all its experiences and struggles as the source of meaning. For Camus, it is not the outcome that bestows value upon human existence, but the pursuit of goals and the happiness derived from such pursuits. This perspective encourages embracing the present and extracting joy from the very act of living, despite the knowledge of the universe's eventual end. Camus' philosophy finds an intriguing parallel with the scientific understanding of the universe. Just as the cosmos may face a big freeze, big crunch, or big rip, devoid of any ultimate purpose or finality, individuals are tasked with finding personal meaning within their transient existence. This philosophy invites reflection on the place in the cosmos and the significance of actions. It is a call to find contentment in the ephemeral nature of life and to delight in the endeavors themselves rather than fixating on the permanence of their outcomes. In this context, the journey through life echoes the cosmic journey of the universe, both filled with events and changes that may seem inconsequential on an infinite timeline, but are filled with significance in the here and now. Much like the stars that burn brightly in the night sky for a moment in cosmic time, human experiences and joys, though fleeting, illuminate life's path. Thus, the search for meaning in an expanding universe becomes not a quest for eternal significance, but a celebration of the moments that define existence. Through the lens of absurdism, the cosmic endgame does not diminish life's value, but rather highlights the beauty and importance of each moment lived within the vast tapestry of the cosmos. Nestled within the vast expanse of the universe, the Atacama Large Millimeter Submillimeter Array, known as ALMA, plays a pivotal role in the quest to understand the cosmos. This advanced interferometer, comprised of 66 radio telescopes, is adept at analyzing the faint whispers of electromagnetic radiation at millimeter and submillimeter wavelengths. It is a tool that allows humanity to gaze into the depths of space, to uncover the secrets hidden amongst the stars. In the chaotic region near the center of the Milky Way, where tens of millions of solar masses of gas coalesce, a supermassive black hole looms, and stars burst into existence while others end their cosmic journey, ALMA has detected something unusual. Amidst this cosmic dance of creation and destruction, a peculiar object stands out for its unique microwave emissions. This object, with the designation G0.024670.0727, has been given the moniker of the Millimeter Ultra Broadline Object, or MUBLO for short. Composed of cold dust and fast-moving gas, MUBLO's behavior deviates sharply from known celestial phenomena. Its singular trait of emitting only microwave radiation puzzles astronomers. Adam Ginsberg, the lead author of the study published in the astrophysical journal Letters, along with his team, meticulously compared the MUBLO to a comprehensive inventory of celestial objects. Their conclusion? The MUBLO does not comfortably fit into any existing category. The quest for an explanation led researchers to consider an array of celestial events and structures, from protostellar outflows to stellar mergers, from intermediate mass black holes to background galaxies. Each hypothesis was systematically evaluated and found wanting. Even the more compelling theories, such as the stellar merger or the presence of an intermediate mass black hole, failed to account for all the observed characteristics of the MUBLO. For instance, the MUBLO's dust mass significantly exceeds that observed in other stellar merger remnants, and the behavior of the gas molecules does not align with the expected patterns of a black hole. The MUBLO, therefore, remains an enigma, a cosmic puzzle piece that does not yet fit. To unravel the mysteries of the MUBLO, future studies utilizing millimeter and mid-infrared observations will be paramount. These forthcoming analyses aim to reveal features of the MUBLO that have until now remained elusive, providing clues that could lead to a definitive identification. Until then, this microwave-emitting object joins the ranks of the unexplained, a testament to the continuous journey of discovery in the celestial realm. It serves as a humbling reminder of the vastness of space and the untold number of mysteries that await, hidden among the stars, challenging our understanding and fueling the human desire to explore the unknown.